So section 2.4, we're looking at linear inequalities. We've got our symbols, some example inequalities, and how to check if a number is a solution to an inequality. Conjunctions are a kind of inequality connected with the word and. You can write it the long way or the short way, and you should be familiar with both. And what this really means is this is a set of numbers between -1 and +3. You think of it as like a range of numbers, like a spread of numbers. And that's called an interval. So if you tell me, for example, to pick a number between 5 and 10, you've just given me an interval between 5 and 10. Whether I can include the 5 and include the 10, well, that depends on what kind of interval it is. Is it open or is it closed? So we're going to talk about those two terms in a minute. And we're also going to talk about what's called a bounded versus an unbounded interval. First thing I'm going to talk about is bounded. Bounded intervals are where each end of the interval, the low and the high, are numbers. Like from -10 to +6. That's a bounded interval. -10 is a number, +6 is a number. Can anybody think of a symbol that we've used in an interval, especially when we talk about domain and range, that is not a number? It's a different symbol we use sometimes. What's the symbol that we use when we're talking about like a domain that's all real numbers?
The infinity symbol?
The infinity symbol, yeah. So when we start to use an infinity symbol, that's not bounded. Because think about it, does infinity ever stop?
No.
No, it's unbounded, it goes forever. So we'll talk about that after. Okay. Bounded intervals start at a number, end at a number. One type of bounded interval is called a closed interval. A closed interval, if you were to graph it, would look something like this. Let's say A is over here, B is over there. You'd have a filled-in circle on A, filled-in circle on B, shaded between. That's a picture of a closed interval. Closed means you can include the low and the high. The opposite of a closed interval is an open interval. An open interval between A and B would look like this. Still shaded between, but you're not including the A and the B. It's like if I said to you, pick a number between 1 and 10, and I gave you an interval like this, that means you can't pick 1 and you cannot pick 10. So you can pick anything that's not 1 or 10 between the two numbers. The other type of interval you can have, if it's not completely closed or completely open, it could be half open. That means you got like one of each. So that would look something like this. Filled in circle on A, open on B, shade between. Open on A, filled in on B, shade between. So those are the 4 different kinds of bounded intervals you can have. There's no other types. That's everything. Because you only have open circles and closed circles. So any question on what it means for an interval to be open, closed, or half open? I guess you could also say half closed. Like I would describe this one half open on the right, I would say this one is half open on the left. All right, so that's bounded. What did I say the other kind of interval was called? The opposite of bounded. Unbounded. So it's very easy to tell if something is unbounded because it will have an infinity or a negative infinity symbol. Something like that. When you graph that on a number line, it's a little different. It doesn't stop. There's an arrow and it keeps going forever. So like this one would look like this. Closed circle on 5. No other circle. Just draw an arrow. The arrow means it's unbounded. It goes on forever. Okay, this one on the bottom. Open circle. Goes on forever. Okay, so unbounded intervals have to have an infinity. And you always put a parenthesis on infinity because you can't reach it. A negative infinity. You can't reach that either. Okay, page 100 in your book has more pictures if you want to see more. But I tried to give you a couple pictures so you could see what they look like.
Yeah, I can't remember. What is the difference between a parenthesis and a bracket?
Bracket means you include the number. Parenthesis means you cannot include it. So, if you have something like that, that means you can pick a number between 3 and 5, not including 3, but you can include the 5. So like you could pick 3.000000001. That's okay in this one. But you can't pick 3. So what we have to be able to do is translate between different ways of saying the same thing. This is called an interval. This is called a graph. Something like that is an inequality. It's 3 different ways of writing the same thing. So let's see if we can translate an interval to an inequality.
To what?
Inequality. So I want to write an inequality for the interval shown below. So this is the kind of thing where you're between two numbers. You're bounded. -3 is the low, 5 is the high. So this is going to have the word and in it. Yep.
What's the definition of inequality again?
An inequality, it has like a less than, greater than, less than or equal to, or greater than or equal to. Let's use X as our letter.
Wait, I'm confused. I thought we were drawing number line. Because you said it's like...
For this one?
Yeah.
So for this one, we're going to write an inequality, which means something like this. X is less than 2,
Okay.
and X is greater than 0. That's not the answer to this one. But that's what it means when it says write an inequality. Write
Yeah.
less thans and greater thans. So doing something kind of like that, anybody think they can tell me, in this case, X has to be this, and X has to be this. So I can start with my X. Yep.
X has to be anything but -3 and be greater than 5.
Above -3. Yep. And what else?
And wait, I thought it was above -5 too, or is it less than -5? Or sorry, not
Less than
5.
Less than or
Equal to 5.
equal to 5. Yep. That's an inequality for the interval right there. X is greater than 3, and X is less than or equal to 5. Now remember, you might see that combined together. You might see the X in the middle, the lower number on the left, the higher number on the right. Both inequalities pointing towards the lower number. These are the same thing. And if you look at it, this is right there. And this is right there. Any question on writing it either way? Both are acceptable. They're both inequalities.
So the lowest number always goes on the left?
That's how I do it, yeah. It's not the only way to do it. You can reverse everything, but I don't want to confuse people.
So how would we use this, like what does this do?
What do the inequalities do?
Yeah.
So inequalities basically set up like an interval of numbers you have to be between. So let's say I had a program that, like at the cash register, that was calculating what I have to charge per price. So if there's a price for people that are, say, less than 6 years old, I charge $20 to come into the park. And then if you're between 6 years old and 18 years old, you have to pay $40 to come into the park. So I could set up intervals, like in a computer program, that would control the price you pay per ticket. Yeah. Or I could also set up intervals, like if I had a lock on a door that was controlled by time. I could say if the time is greater than 9 o'clock at night, it'll automatically lock the safe. And if the time is, before 6 in the morning, lock the safe. So that way the safe unlocks at 6 in the morning and it stays open till 9 at night, maybe at like a business or something. So it would be like a program intervals. I tend to think about programming stuff because that's just, but I could probably think of other stuff too.
So when we write like our answer for a problem like this, would you want the bottom one or the top?
If it didn't say, you could do either one.
Okay.
If it was a multiple choice and you came up with the top one and I listed the bottom one, you'd have to understand they're the same.
Okay.
Yeah. All right, let's try this one. So this is an unbounded interval because it goes on forever. What kind of number would you be allowed to pick in that interval? Yep.
Any number greater than -4.
Any number
Or equal to?
or equal to.
Great number, yeah.
So basically, any number greater than or equal to -4. That's all you have to write. Some people say, well, don't you have to say greater than or equal to -4 and less than infinity? No, everything's less than infinity. You don't have to say that. So anything greater than or equal to -4. So unbounded intervals are actually simpler to write down than bounded. There's less you have to write. All right, how about this one? First of all, is this bounded or unbounded? Yeah, it's bounded. So when it's bounded, you usually need an and you have to say two things.
Would it be x is less than or equal to -8?
So that would mean you could pick something smaller than -8. -8 is the smallest.
X is greater than or equal to -8.
Yep, so we got to be greater than or equal to that number, but we also have to be
Less than -3 or equal to?
less than or equal to -3. Yep. So you can write it that way. Or put the small number on the left, put the bigger number on the right, and put your inequality symbols always pointing to the left. Yeah, that is not the only way to do it, but we'll just stick with that. All right. Any question taking an interval and changing it to an inequality? Let's try taking a inequality and changing it to a graph. Okay, so now we're going to graph it. And what's the difference? It's just a different way to write your answer. It's not like writing an inequality is the right way and graphing is the wrong way. Just different ways. You'll already have an inequality line on the test. You won't have to draw your own line. Okay, what kind of circle do I need on the shape?
A closed.
Closed circle. And shade to the
Is that right?
yeah, shade to the right. This is unbounded. Unbounded means it's going to have an arrow that just keeps going. about this one? X is less than 5.
An open circle on 5 and then shade to the left.
Yeah, this is good. Open circle on 5, because we can't include it, shade left. Any questions on that? Okay, let's try this one. What am I gonna, how many circles am I going to need for this one? Yeah, I'm going to need 2. The first circle goes on what number?
-1.
-1. And it's closed. And Brett, my second circle goes on
3 and it's open.
3 and it's open. And I shade in between because it's bounded between. So that's taking an inequality and writing a graph. Inequalities, graphs, intervals, different ways of writing the same thing. Okay. Questions on that? All right, so when we are solving inequalities, we pretty much use the same steps as when you're solving an equation, except there's one thing that can happen. If you multiply or divide by a negative number, does anybody remember what you have to do? You're solving an inequality. If you multiply or divide by a negative, you have to do something. Yeah?
Do you have to make it a positive by using the absolute value?
No, we're going to talk about absolute value in a little bit. This doesn't have absolute value, though, in it yet. But we will talk about that. Something to do with the inequality symbol. Yeah?
Do we have to add the negative to the other side?
So again, we're going to talk about something like that in a little bit, but just not with this question. But when you multiply or divide by a negative, you have to flip the inequality. If you remember that, you have to flip it. So like if you had negative 2x is less than 10, and you solve that by dividing each side by negative 2. The answer is not x is less than negative 5. You need to take that and flip it so it's x is greater. Okay, but the only time you flip it is if you multiply or divide, and it has to be by a negative. Not every problem that's going to happen. Some problems it does, some problems it doesn't. Okay, just depends on the problem. All right, so let's see if we can try the steps for solving an equation on an inequality, and if we do divide by a negative, we will have to fix it. Okay, so on the left side, what's the first thing I would do to get rid of my parentheses?
Distribute the 3.
Yep, so distribute the 3. 3x minus 3. Okay, so I distribute the 3 out. Next thing I need to do on the left-hand side, I still got something I can simplify.
-3 plus 2.
Yep, and Logan, what's negative 3 plus 2?
Negative.
Yep, negative 1. Okay. Caleb, what would be the next thing I could do to get all the x's on the same side?
You could subtract 3x.
Okay.
Or, yeah.
You want to do it that way? Yep. Subtract 3x from both sides. That's gone. Now, since I subtracted and put all the x's on the right, let's put all the numbers that aren't x's on the left. So, Caleb, how could I move the 6 over to the left side?
You can subtract 6.
Yep. Subtract 6, and that's gone. We get negative 7 is less than or equal to 2x. Alejandro, what would my last step be to get x alone?
You could add -7 equals 2.
So what operation do we have between the 2 and the x? Like if you were to read that to me. 2 times x. And what's the opposite of times? Divide. Divide both sides by 2. And we get -7/2 is less than or equal to x. And it's okay. I would put the letter on the left side like this. X is greater than or equal to -7/2. Is there any question how I change that into that? Yeah, I just.
Is there a reason why?
I guess just usually the letter is on the left side. Yeah. Okay. So specifically when I asked Caleb a certain step, the way he chose to move the x's to the right, it avoided having a negative in this problem. If he had told me to subtract the 5x to the left, then you would have had to deal with a negative. But you would have gotten the same answer.
All right, you go back now.
So I'm going to show you, even though we didn't need a graphing calculator to solve that, I mean, we solved it pretty quick. I'm going to show you how you can solve it on the calculator in case you have one you don't know how to do. Okay, I'm going to show you two different ways. The first method involves getting 0 on one side of the inequality. So if it doesn't have 0 on one side, you need to make it so it has 0 on one side. Okay, so we're going to do that one. 4x minus 1 is less than 2. Does that problem have 0 on one side of the inequality? No. What could I subtract from both sides and then it would? Yeah, so subtract the 2. Now we have that. So the next step, it says, is to calculate the root. Well, we can't do that until we type it in. So let's type in 4x minus 3. If there's anything in there, just clear it out. So I typed it in. I'm going to do zoom 6 just to reset my window in case somebody changed it. All right. And now I'm going to calculate the root. Does anyone remember what I pressed to do that?
Second trace.
Yep, second trace.
And then 0.
And then we want to find the root or the 0, same thing. Pick a point that you know is somewhere to the left. I'm trying to find this point where it crosses the x-axis. So make sure you're to the left. Hit enter. Go to the right. Hit enter. And on my calculators, you'll see those dotted lines putting like an area that it's going to look in. Just hit enter one more time. And you should get
Wait, so we go to second and where?
calculate and then 0. Calculate is 0 is option 2.
Oh, I see.
I think it's option 2. Okay, so that's the 0. But the question here is not where is it equal to 0. Where is it lower than 0? This line is lower than 0 in this section right here. This section up here is above 0. I want the lower section. So what kind of x values would I have to pick to land on the blue section that I circled? Would I pick x values lower than 0.75? Or would I pick x values higher?
Lower.
Lower. Yeah, if you pick one higher, let's say you pick 2. 2 is like way up there. That's not on the section of line we want to be on. Pick a number lower than 0.75. Try -1. -1, it's like you're way down there. That's what you want. So the answer to this inequality is all numbers from that point and lower. Okay? So actually lower, just lower, not equal to. It's not equal to because there's no equal to in the problem. If it said greater than right there, then my answer would just have that sign flipped. It would have been above 0.75. So that method involves rearranging it because you got to get 0 on one side. The second method doesn't. You don't rearrange anything. So I'm going to do the exact same problem again. So we're going to get the same answer. But I'm going to show you the other method. In this method, leave it the way it is. Put the left side of your inequality in y1. Put the right side of your inequality in y2. And once we put each of those in on the calculator, I'll show you what we're going to do. Can I make the right side bigger so you can see it? Good to the left? Okay. We're going to calculate an intercept. Okay. So I put it in just like it said, 4x minus 1. Put in 2. Hit graph. Okay, that's y1. I'll circle it in blue so we remember it's blue. Y2 is the one that is in red. Okay, find the intersect. Where do I press to see where they cross?
Second calc.
Second calc.
Go to intersect.
Yep. Since there's only one place they cross, I can just hit enter 3 times. And I've got the intersection point. 0.75. Now looking at what we're solving for, we are looking for where 4x minus 1, that's the blue one, is under the 2, that's the red one. So where is the blue graph under the red graph? Is the blue graph under the red graph to the left of this point or to the right of that point? To the left. Anything to the left of that number right there. So anything to the left of 0.75, the blue graph is under the red one. And that's what they wanted you to solve for. Okay. So there's 2 ways you can solve that one. I don't think you need a calculator to do that at all, because all you really need is just to add 1 and divide by 4. You get your answer. But that's how you can solve it if the inequality gets a little more complicated and you get stuck. So any question on either method 1 or method 2? They're the same. Each method will work in any case of the other one. You can use either one. Doesn't matter. All right, so a double inequality. Let's look at this one. The way you solve an inequality like that for x is you need to break it apart. Break into 2 problems and solve. Let me show you what the 2 problems are. There's one that I just put a box around. So you're going to write that one down. There's 2. So we write each of those separate, and we solve each one. I'm calling it a double inequality because it's got 2 inequality symbols in it. Does anyone remember the other name I used? It began with a C earlier on.
Conjunction.
It's a conjunction. And a conjunction always has what word in it? And. So you always need to write down the word and when you're solving it. Okay. Can someone give me the first inequality that I would solve? Yeah.
Negative 8 is less than less than 2x.
Negative 8 is less than 2x. Okay, we'll come back to that one. And someone else give me the other inequality. Yeah, go ahead.
2x is less than 12.
2x is less than 12. So to solve both, you're just going to divide by 2. And again, that's okay if you wrote that. I mean, I wouldn't mark it wrong. But generally, you're going to see me write the answer with the letter on the left. So x is greater than negative 4. And what would you get when you solve this one?
X is less than 6.
X is less than 6. So if you can pick numbers between negative 4 and positive 6, is that bounded or unbounded?
Bounded.
It's bounded. There's a limit. There's a number on each end. And is this type of interval open or closed? It's open because you can't use the 6. That'd be an open circle. And you can't use the negative 4, open circle. So as a picture, it would look something like this. Open, open, shade between. You didn't have to graph it. Okay, I'm just showing you what the graph would look like. What I circled is the answer. Good. Any question on that?
So it was just, they're both open, just the parentheses?
They're both open because they don't have the equal to under the inequality. Okay, now we're going to talk about what I think you mentioned earlier, when we have to take and split it into 2 problems and we make a number on the other side negative and that kind of stuff. So to solve an absolute value inequality, the first step, it's the same first step as yesterday. The absolute value needs to be by itself, like this. That's an example where there's nothing outside the absolute value. This is an example that is not good. Okay, we wouldn't want that plus 2 there. We'd have to do minus 2 and move it to the other side. So now we're going to split that into 2 problems. Does anybody remember when this was an equal sign? How did we get the first problem we split it up into? Remember, how do we get because it's going to split into 2.
3x minus 4 would be greater than 5 and then greater than negative 5, or less than 5 and less than negative 5.
So what was the wording we used yesterday? Take the original one and do what to it?
Don't you do it like 1 plus and like 1 subtraction?
Okay, so we'll talk about that, but what about the first one? The first one was just take what they give you and do one thing to it.
Take the bars away?
Just take the bars away. Don't change anything else. 3x minus 4 is less than 5. Okay, so the first one, that's the simple one, right? Just take the bars away. Now the second one, you take the bars away.
And then you switch the 5s to the opposite.
Right, that number is going to, I want to erase that. That number is going to become opposite. And there's one other thing that's going to happen with an inequality. We take the bars away, make that number the opposite,
Change the sign.
and that sign is also going to change. So that's That's the extra thing. So first inequality, take out the bars. Second inequality, take out the bars, flip the sign, and make the number the opposite, just like we did yesterday. So there's two words we've used in this section. Conjunctions, we've been using the word and. What's the other word we've been using? Or. When you write your final answer, it's either an and or an or. And you can't just pick randomly. It has to be a certain one. The way you figure out if your final answer has an and or an or is you go back to the original problem after isolating the absolute value. Okay, so look at the original problem after you've isolated the absolute value. If the original problem had one of these two symbols, less than or equal to, it's going to be an and. If this one, if it has a greater than or equal to, it's an or. And the way I remember that these two symbols are or, rather than pronouncing this greater, I pronounce it greater. Okay, think of it like that. It's a greater symbol. So greater is or. Less than is and. Greater or. Try a couple of those, and then we're just about there. Okay, so first question you ask yourself, is the absolute value by itself on one side? In this one?
Yes.
Yeah. So that's fine. So you don't have to do anything to get it by itself. We can already figure out which word this problem is going to have in it. Looking at the symbol, the inequality symbol. Is this going to have an and or an or?
And.
This one's going to be an and. Less than, and. Let's go like this. You don't have to write the word and now. You have to write it at some point. So I don't forget, I like to write that down.
What made that thing and?
Because this is a less than. Less than is always and. Okay, now, can somebody give me my first inequality that's not going to have bars anymore?
X minus 3 is less than 3.
X minus 3 is less than 3. Perfect. And my second inequality, this one you got to remember to do a couple things to it.
X minus 3 is greater than negative 3.
X minus 3 is greater than negative 3. Yep. Now we just solve each one, and that's our answer. So X is less than 6. Add 3 to both sides. And you tell me, what's the other one? X is greater than 0. Yep. And it did say to graph, so let's set up a number line. What kind of circle on 6? What kind of circle on 0? And we shade
In between.
and is between. Yep. If that was an or, we usually end up shading in opposite directions. question on that? Okay, so that was a less than. Let me look at that one. That's a greater. What was this one? It's a greater. Another less than. No, that's it. Let's just try to tell. Okay. Is the absolute value by itself?
Yes.
Yep. Greater. It's a greater symbol. So what word do we use?
Or.
That's an or. So when we graph it, it's going to usually end up shading with arrows going the opposite way. Okay. First inequality would be?
3x minus 2 is greater than 1.
Greater than 1. And second inequality?
3x minus 2 is greater than negative 1? Or less than?
Less than, yeah. So we got to flip that sign and make the number negative. So that's going to give me 3x is greater than 3, which means x is greater than 1. Or, so the way that would be set up on the test, I might have a drop down where you click it, and the choices would be and or. So you'll see 2 boxes, and then you click it and pick and or or. This one is 3x is less than 1, which means x is what's my inequality going to be?
No. Would it be
Less
than
than. And then when you divide each side by 3, yeah, it's going to be 1/3.
How did you get rid of the 2?
Plus 2, plus 2, and negative 1 plus 2. That's how I got 1. Okay. So I need a number line. Just like that. I need, let's put 0 and 1. Okay. What kind of circle on 1? Open. And which way would I shade? To the left, are those numbers bigger than 1 when I go to the left?
No.
We want all numbers greater than 1. So shade,
To the right.
we want to the right. Okay. What kind of circle on 1/3? Open, right about there. And we want all the numbers that are smaller than 1/3.
To the left.
That's to the left. That's generally what an OR looks like. Any question on that? All right. Last question. All right, so this one's a fraction. It's got absolute value in it, but it's a fraction. Okay, so when we look at that, something divided by something is bigger than 0. What kind of numbers do you have to divide in the top and in the bottom if you want to guarantee you get an answer bigger than 0? Yeah? A positive divided by a
Negative. No.
another positive. What else could you do besides dividing a positive by a positive? Yep.
Making one of them 0, like either the numerator or the denominator.
We'll come back to zeros, but no, nothing with 0. Thinking more and more about that, but we're going to come back to 0. That is important.
Making both of them negative.
Making both of them negative. Let's call this case 1 and this case 2. I don't care what kind of numbers you pick. If you pick 2 positives and divide them or 2 negatives and divide them, it will always come out bigger than 0. One of those cases is impossible here. Which one of these cases cannot happen on the left-hand side?
A negative because absolute value can't be negative.
Right, you're never going to get a negative in the bottom, no matter what you plug in for x. Case 2 is impossible in this problem. So that means this problem has to be a positive over a positive. Well, we already know the bottom is always positive. There's nothing you can do to make it negative. So all you have to do is guarantee that the top is positive. If the top is positive, that means the top is bigger than what number?
3.
Well, just in general. The top has to be a positive number. It has to be bigger than 0. The top has to be above 0. The bottom already is because of those bars. What would that mean x is? Yeah?
Greater than -3?
Yeah. X has to be greater than -3. As long as x is greater than -3, the top will always be positive, the bottom is always positive, and you'll have a positive over a positive. Now, to get back to something Kyle said. He said something about zeros. X has to be bigger than -3, but there's one number you're not allowed to use, even though it is bigger than -3. Then, which number is it?
0.
0 you can plug in, that's fine.
Positive.
What is it? 2. Why can't x be the number 2?
Because if you put it on the bottom, it makes the bottom 2.
Right, and you can't divide by 0. So even though 2 is bigger than -3, you can't plug a 2 in for the bottom because that would divide by 0. So that is the answer to this problem. Any number bigger than -3, but not the number 2. And that's solving linear inequalities. The video was a little bit short because I didn't start it right away, but I tried to go back over the stuff we didn't record. Okay, so those are the questions for tonight. Okay, it kind of jumps around a little bit. I think it's about 18 or 19 questions. Okay, what I'm going to do now is I'm going to pause the video. I think I'm going to have enough time. I'll put the test topics up, and that's what will be on the test for tomorrow. Okay, so that's the list of topics that will be on the test.
Am I gonna